Okay, we're up to 32 participants, so I guess we can get started. Hi, everyone. Thanks for joining. Good morning, good afternoon, good evening, wherever you are in the world. And welcome to this first webinar of a mini-series of 4 on data-powered positive deviance and the work that we've been doing together with the GIZ Data Lab, the UNDP Accelerator Labs, and the University of Manchester. This is a first in a couple of ways. As I mentioned, it's the first in a mini-series of 4. We will provide you with more information on the upcoming webinars at the end of this one. It's also a first because it's our first webinar held on Teams, so please bear with us in case there are any glitches. What we're going to present today is still work in progress, and essentially what we wanted to do is open up weekly calls that we have as a team, and show you kind of our way of working, what materials we mobilize, and so on. Essentially, how we share and discuss the knowledge produced. All this in the sort of broad idea of working out loud. So with that very brief introduction, I'll pass it over to my colleague, Andreas Pavelke. Over to you, Andy. And thank you, everyone, for joining.
Thanks, Jeremy. And just a note before I start, we're recording this webinar, so just a note for all of you, so you're aware. Now, I'll say a few words about the initiative before I hand it over to my colleagues, Basma, Guna, and Hodan, who'll talk about the method and the pilot that we're running in Somaliland. So data-powered positive deviance, or DPPD, is both an initiative, a global initiative, and a method. And so the method will be introduced by Basma right after me, and the global initiative, which was really set up to really find a way or find out if we can actually use different types of data to identify and then actually promote innovative local practices to solving problems. So when we set up the initiative, we knew this couldn't be done by one single organization because it requires so many different types of expertise. So the initiative was set up by the GIZ Data Lab, the UNDP Accelerator Labs Network, the University of Manchester Center for Digital Development, and UN Global Pulse Lab Jakarta. And all of these organizations, and I'm sure many of you will know them, have very deep expertise in specific areas that we need to make this method work. So from data crunching to ethnographic field work to some specific domain expertise that is required to actually make sense of the data that we analyze. Now, we also knew that this type of work that we do requires an experimental or quasi-experimental approach, because there's very little known about if and how the method actually works. So we started a couple of pilots in different countries, sectors, looking at different challenges, using a range of different data sources to have really sort of a setting that would allow us to explore and experiment under different conditions and see in what conditions and what environments the method actually works. And so we have a number of pilots, 4 of which we'll be talking about over the next 2 weeks. And today we'll talk, as you all know, about Somaliland. And so all the pilots are very different from one another. But what they all share is there's one common idea, or maybe even philosophy, that is made up of 2 things, essentially. So one is that we believe there are solutions out there that work, and that more often than not actually come from those who face a particular problem. The second one is that we think, with all the data available to us nowadays, we can use the data not just for problem analysis, but actually finding signals in the data that point us to effective solutions. So these 2 things is what's common across all the pilots that you'll hear about today and the next days. Now, the focus of this webinar is really about the pilots, and I just wanted to say that over the next 2 weeks we'll be talking about the other pilots, but also the next weeks and months you'll hear more from us about the learnings that we documented. We'll be sharing materials on how to actually apply the method. So this is just the first really instance in a number of events and a number of ways we'll be sharing our learnings. I should also say that there is 4 pilots that we'll be talking about. There's another 2, one on COVID-19 and one on rice farming in Indonesia, that are also part of the global initiative. and that you can find out more about in our blog, or just writing to Basma or Andreas or others here in the group if you want to learn more about them. Okay, so with that, I'm handing it over to Basma for her to talk about the DPPD method and really see how it works before then Hodan and Gunnar talk about the specific pilot in Somaliland. And then at the end, we have quite some time reserved for Q&A. So you can put questions in the chat here, or just raise your hand, but I'll say a few words about this after Hodan, Gunnar, and Basma have presented. Basma, over to you.
Thanks, Andy. Hi, everyone. Before talking about the data part positive deviance method, it's important to give you an idea about the positive deviance approach. So the positive deviance approach is based on the observation that in every community, there are individuals or groups who are able to achieve better outcomes than their peers, despite having similar challenges and resources. And identifying those positive deviants and scaling and amplifying their successful strategies and solutions is what is referred to as the positive deviance approach. This approach has been proven successful in more than 60 countries across the globe, according to the Positive Deviance Initiative, and it has been applied in a myriad of domains, including enhancing school retention and fighting FGM. But the large success of positive deviance can be attributed to Jerry Sternen, who applied it to solve the problem of malnutrition while working in the Save the Children Foundation in Vietnam. So what Sternen did is that he looked into the families and observed the families of extremely well-nourished children in very poor and vulnerable communities in order to identify simple, affordable, community-inspired practices that could be scaled. Simple as much as like adding tiny shrimps and sweet potato greens into their food and having more frequent meals and washing their hands more often. And by scaling those extremely simple practices, he was able to rehabilitate an estimated of 50,000 malnourished children in 250 communities and reduce malnutrition by 80% in 2 years. So what is this idea about integrating big data and positive deviance? So my PhD research is asking the question of how can we leverage big data in the positive deviance approach? And in order to understand this, it was important to analyze the current state of positive deviance and try to identify potential opportunities and potential limitations of applying big data in positive deviance. So some of the opportunities that are evident in using big data in the positive deviance approach is the time and cost needed for data collection. So the positive deviance approach traditionally is based on collecting primary data collection in order to identify the baseline from which positive deviants are identified. This process is time and labor intensive with cost proportional to the sample size. But there is an opportunity in using existing readily available digital data sets that reflect a certain performance indicator and using this data set to create this baseline from which positive deviance is identified. Also, a challenge that is also linked to the conventional positive deviance approach is that since the time and cost needed to collect data is extensive, conventionally, the samples of PDs are small. And due to the relative rarity and because we're looking into the exception, when you have a small sample, it's harder to identify those positive deviants. This can also be viewed as an opportunity for big data because we're covering larger samples, and accordingly, it is easier to identify a larger sample of positive deviants, and it will be easier to generalize our findings and conclusions. There's also the opportunity that comes with the large sample is that you would be able to also analyze positive deviance at different aggregation levels. So you can not only look into individuals, but you can also look into communities, or you can also look into spaces. And there's also this good idea of, instead of looking into performance as a cross-sectional reflection of performance or at one instant of time, due to the longitudinal coverage of big data, it's possible to look or view performance in a dynamic form and being able to identify PDs over time. And finally, the large coverage and the large coverage of big data and its ability to go beyond a controlled environment enables us to analyze performance of systems instead of analyzing performance of individuals. And this expands the scope of PD because in the DPPD method, it's possible to use it as a systemic lens where you can see the interactions of communities with development interventions or with infrastructure or with certain policies and trying to understand more the system behavior. But there are limitations that comes with the use of big data. Limitations like big data is usually a decontextualized data. So in order to be able to identify or to be able to capture the context, it's important to augment this data with traditional data sources like interviews and surveys and official statistics. It's also thin because due to its large coverage, it's focusing on one dimension or few dimensions. And to be able to have a holistic view of the phenomena you're understanding, it's important to complement it with different dimensions of data. And finally, if we were able to identify who are the positive deviants and what is happening, it's also hard to use or rely on big data to understand why. And hence, in the Data-Powered Positive Deviance Initiative and through the Data-Powered Positive Deviance Initiative and the different partners, we are trying to develop a method and refine a method that combines both traditional and non-traditional data in order to identify and understand positive deviance in new ways. So what we're doing is that we're making use of the large sample of data to identify those potential positive deviants and narrow down our qualitative search space where we will go there and inquire about positive deviance and start this qualitative time and cost intensive process of data collection. And to develop this method, as Andy mentioned, we're experimenting the use of digital data sources to address real development challenges in different domains using different types of digital data and using different units of analysis. So we're looking into individuals or individual farms, we're looking into communities, we're looking into geographical spaces in Mexico. So we're trying different types of units of analysis. So if we look at the DPPD method in a very abstract and simple form, so the first step of the conventional approach is to define the problem. But in the DPPD method, it's important to have a problem solution fit stage where basically we are defining the problem, that's one thing, and at the same time, we're making sure that the DPPD method can fit as a solution to this problem, because we're not suggesting that DPPD or using big data could be used as an alternative of the conventional approach, but we're saying that it can be used in some domains for certain challenges and we could retain more value by using it. And in order to identify this problem solution fit, it's important to ask 3 questions related to suitability, feasibility, and desirability. So when it comes to suitability, we ask the question, is the positive deviance approach a suitable approach to address this problem? And by suitable, it means that it is an adaptive challenge. It requires a behavior change. It's not a technical challenge that just requires a technical solution. When it comes to feasibility, it's important to make sure that it is possible or we have access to the data and the capabilities that would make this method feasible. And when it comes to desirability, we're ensuring that there will be no harm done to the observed units, and we're ensuring that we're taking into account all the unintended negative consequences that could result from this analysis. So this is the first part, which is the problem solution fit. And the second part is about determining positive deviance, or the second stage is about determining positive deviance. And when we determine positive deviance, we go through 4 main stages. So the first stage is the homogeneous grouping. We are aware that as we go larger in terms of geographical scale, as we are taking into account different structural factors, and to be able to ensure that we are comparing PDs within controlled environments that are having very similar structural constraints, it's important to divide this population into homogeneous groups. This way, when we identify positive deviance, we're increasing the likelihood that their performance is due to behavioral and transferable factors and not due to structural factors. The second part will be about measuring the performance of those positive deviants within those homogeneous groups and identifying positive deviance in context within those homogeneous groups. And finally, validating those positive deviants in order to start the qualitative PD inquiry. So here you can look at it as a funnel. And how it starts, that we start with large populations, we are measuring their performance using a recorded or observed performance measure that is digitally recorded or observed. And then the study population is narrowed down into homogeneous groups. Within those homogeneous groups, we're identifying potential PDs. Within those potential PDs, we are validating those PDs, and then the validated PDs will be the one who are targeted for the qualitative inquiry. So we start by large populations and we end up with a small sample of information-rich PDs for the qualitative inquiry. And the use of the non-traditional data and the traditional data varies according to each stage. So there's more reliance of non-traditional and digital data at the early stages where we're narrowing down, and there's more reliance of traditional data and interviews and surveys as we go down the funnel. The next stage after the problem solution fit and determining our positive deviance will come the process of discovering the underlying practices, designing interventions to disseminate those practices, and monitoring and evaluating those PZ interventions. And those three stages will be the fieldwork stage. The focus of the pilots in the Under the Hood series and what they will be presenting mainly will be the first two stages. And now I will leave the space to my colleagues, Gunnar and Hudan, to be able to present the Somalia pilot. Thank you. So I'm moving to Mira now. Hudan?
Yes, thank you, Basma. If we can just go to the first slide.
Yes. Are you able to see my screen, Hudan?
Yes.
Okay. I'm going back, sorry. Yes.
Hi, everyone. Good morning, good afternoon, good evening. Myself, Hudan Ahmed. I'll start introducing the pilot for Somaliland. But first of all, I just need to say thank you to all of the team from Accelerator Lab Somalia, GIZ Project and Sustainable Land Management, Flora Friste, University of Manchester, GIZ Data Lab and the Accelerator Lab global team. Next. So first of all, let's start. I'll just give you a bit of context on Somaliland. Somaliland is at the north of Somalia. It's an arid part of the world where most of the population is, or a large part actually, are pastoralists. Some estimates put it at around 55%. And pastoralism is just more than a livelihood. It's actually a way of life. And it's represented as the backbone both of the economy and the culture. However, this form of livelihood, way of life, is highly vulnerable to climate variability, especially because of the dependence on grazing and water resources. Next slide. Okay, so let's just go to the problem directly. Knowing this context and this part of the country and part of the world, there was a very devastating drought that happened around 2016 to 2017. And it not only hit Somaliland and Somalia, but also all of Horn of Africa. You could see the graph is a bit evident on how much it was impactful. Much of the crop resources were lost, as well as pasture, but there was also the effect went to and affected the ability of pastoral resources to regenerate. Water shortages were common. As well as livestock, and a huge number of livestock were lost. Households became destitute, and many of them ended up being IDPs around major cities. But zooming a bit out of this very critical time, we will see that, and make it like looking at it on a general scale, we see that pastoralism as a way of life is actually out of balance, especially because of factors such as population growth and the increase in the number of settlements. These factors affect the use of natural resources, adding pressure on already limited natural resources, and that is also exacerbated by the cyclic droughts. If you've heard in the news, the droughts or the window of time between each drought and the other is becoming less and less, not only in Somaliland and Somalia, but generally the whole of Horn of Africa. And this, because of this reduction in time between droughts, we have severe land degradation. And this affects people's not only life, but also livelihoods. Thus, we see that protecting natural grazing resources is very important, and we believe it could be through rangeland management. Next. Thank you. So going through the literature, namely a report by Ilri in 2018 on the dynamics of natural resources in Somaliland and its implication on livestock production sector. We see that the problem that we identify is very much explored in detail, where they saw that population growth and climate change were not only putting strain on this form of livelihoods, but it would be also a possibility of further having a potential instability. It could be a source of instability. And there were other factors identified as well, which exacerbate this problem further, like rural-urban migration, the mushrooming of more settlements and land enclosures, and then land degradation. But then there's a lot of opportunities there, especially in terms of designing new interventions to see and solve this issue. And they identify top-down approaches as well as bottom-up approaches. But how does this connect to positive deviance? So we define positive deviance as communities within pastoral communities within Somaliland who were able, through their practices or behavior, to manage their areas, manage their natural resources, especially after the advent of droughts. Our unit of analysis was identified as a buffer zone around each settlement of around 5 kilometers and having 2 kilometers between each village. So what would these PDs tell us, you might ask? Well, we might find a mix of some of the landscape interventions or activities that might work very well together without actually having any adverse effect on the environment. We might find within these PDs that we defined some individual, household, or even community adaptation strategies that could help recover after droughts. So then we asked ourselves, how can we monitor this remotely and what data sets could we use? One of the things that was could readily be seen from geoinformatics is the loss of biomass or natural vegetation. Could help us find or gauge how much a certain area regenerates or regenerates. So and some of the we could like soil or water conservation methodologies that could also be seen through Earth observation data. So next we'll go to the refining of the methodology and the study. Next. If you could just zoom in a bit, this is the flow chart of our study. First, we have the definition of the problem, where we use stakeholder validation as a first step to refine our understanding of the problem, to see if the outcomes are actually ones that are desirable, and also help us more or less design the whole project. Then comes the quantitative part, where we would determine by using the data sets that we have and with the knowledge of the context, we would determine potential positive deviance. And this would be also validated, and we would take it over to the qualitative part of the study. Here, we would more or less go into discovering the underlying characteristics of the PDs, doing interviews, observational study of the positive deviant villages to see what makes them actually positively deviant. And then the next part would be planning or designing the interventions, what transferable knowledge can be transferred into either policies or community-based interventions, or even a mixture of it all. Okay, next slide. Thank you. Okay, so first part of the, we'll just take you a bit on a detailed tour of the stakeholder meetings. The understanding of the context was very important for us to have these meetings and to ensure the desirability of the outcome that we set out. And that was mainly to see if there is a link between a healthy rangeland and if it's actually better for livelihoods. And also to get kind of a leadership buy-in just from the beginning, from the start. We had meetings with the agri-pastoral community, with government agencies, Ministry of Livestock and Fisheries, Ministry of Rural Affairs, and the Ministry of Agriculture, as well as sister agencies, FAO and our local UNDP Resilience and Climate Change colleagues, as well as the University of Hargeisa. Okay, next. So, firstly, we had to choose an area of interest and as our sample where we would be studying. So we chose West Gulis, and West Gulis is a large area that has a variety of geological and landscape, and there's also a variety of crops and variety of crops, livelihoods, as well as it cuts through 4 administrative regions, and we chose it because it was defined as a majority pastoral community lives there, and it is more or less easy to access. We found within this region 314 villages, and with each, as you can see in the picture here, we have like a 4-kilometer buffer around each village, which represents our unit of study. We did a bit of aggregating villages that are nearby to each other because we assumed that they would share resources more or less, and we got around 216 settlements. And to give you a bit more on the quantitative phase of analysis, I'll give it to Gunnar.
All right, thank you, Hodan. I will just quickly share my screen. So I want to take you through the methodology of the quantitative analysis. Before I dive into the actual methodology, I would like to bring your attention to one big weakness of remote sensing data, actually. And remote sensing is one of our main data sources. In remote sensing, we are seeing the landscape from space. So it's pretty easy to get very interesting results using remote sensing data, but it's almost impossible to interpret remote sensing results without expert knowledge about the area, without having in situ data and experience on the ground. So what we can do here in this phase is basically pointing the process of determining positive deviance into the right direction or into the right area. We can't possibly determine that just by looking at satellite imagery and analyzing it. So Hodan already covered how we determined our units of analysis, and I just want to take you through the steps we did for the homogeneous grouping and the local SAVI scaling. You don't have to read this flowchart here. It's just a visualization of what we did, and it's mostly for us to keep an overview, so I don't expect you to read and understand this right now. What we are doing here is we are determining outliers, and statistically speaking, positive deviants are outliers. So to be able to do that, we have to be careful not to compare apples to oranges. So we had to somewhat control for biophysical and climatic variability, and we needed to divide the area covering those zones into homogeneous groups. And we did this by identifying areas with similar land capability, or in other words, groups with similar potential productivity of vegetation, and we grouped them together. This means that areas belonging to the same group or same homologue would produce equally healthy rangelands in the absence of human land use. And this will help us identify context-specific practices that are not separate from their localities. So we have to keep location in mind. We clustered our entire geographical region on a pixel basis using an existing land cover dataset, which you can see here. This land cover dataset is from 2019, and we also had remotely sensed rainfall data. And this rainfall data is summarized for the period 2016 to 2020. And we calculated rainfall for every pixel using the mean of the rainfall sum of each growing season. So the growing season we took from April to November. This includes a small dry season in the middle, but nevertheless we summarized it like this. And then we used a clustering technique using these two inputs, land cover and precipitation, to come up with our homogeneous groups. And here we can see the 16 groups. It's a really colorful image to not give any false expressions of land cover or something like that. We took some abstract colors, but you can see the 16 homogeneous groups we analyzed further. So the next step would be the SAVI scaling. So we had to determine some measure of performance, and we choose rangeland yield and regeneration as a representative measure. And to capture the rangeland performance of each community, we used the soil-adjusted vegetation index, which is a remote sensing-based vegetation index that adjusts for effects of soil brightness, for example, and it makes it very suitable for arid regions, such as the West Golis area we can see here now. We used Sentinel-2 satellite imagery to compute the SAVI for each pixel in our area of interest, and used this for the further analysis. To identify settlements with positive vegetation development, we applied a method called local scaling. And basically what that means is that we compare vegetation productivity to the potential maximum per pixel within a homogeneous group. And that's why we created those homogeneous groups. So we calculated the SAVI sum per season. So SAVI was the vegetation index. We summarized that per season between 16 and 2020. And then we calculated the difference between the measured SAVI value and the potential maximum SAVI value of the group. And by doing this for all 5 years, we computed a linear slope of the difference representing the temporal development of vegetation productivity. It's a bit technical, I admit. You will be linked to a blog post later on. We can read on the details. We then computed z-scores for those pixels, and we took z-scores as a measure to standardize slopes in the same homologue. And we can see the results of this in a summary view over here. So here, for example, we can see the settlements Hodan just presented, and the red ones have a negative z-score, and the green ones have a positive z-score. The darker the green, the more positive the z-score. We also did another method of summarizing this, not only by taking the mean, but by looking at the proportion of very high z-scores. And the settlements selected by those two methods overlap greatly. So we took the top 10 settlements from this method and the top 10 settlements from here, and this yielded 13 settlements in total. And then we did a visual inspection of those 30 settlements. And I will just take you quickly through this process of visual inspection. So we came up with a small exclusion logic for our visual inspection. So it basically went like this. We looked at the potential PD area and wanted to see, are there settlements? If no, it was ruled out directly. If yes, was it a purely agricultural in the cropland sense of the word? If yes, then it was ruled out. By the way, that didn't happen. Did we see human intervention in high-performing areas? So these areas which were responsible for this very high score, if no, it was ruled out as well. And if yes, we deemed it a potential PD. And I will just quickly show this to you. It will take us a few minutes and then we are done with the presentation. I'm looking forward to your questions. So here we can see 3 potential PD areas I wanted to show you. And I will start with the northernmost one, Karinkulan. So here we can see the Z-scores. So green Z-scores correspond to very good performance and red Z-scores respond to very bad performance. And we can see clearly that here are regions, or here's one region doing extremely well. So we try to investigate and see what's happening there. And when we did so, we quickly realized that there seems to be little to no human activity in this area. So here we can see it's open shrubland, and we determined that it's possibly because of increasing seasonal rainfall. We can see there's a seasonal riverbed over here, but what we can't see is any sign of human activity in this area. Hence, we ruled it out rather quickly and determined, okay, that's not what we are looking for in this project. So off to the next area, which is Gaan Diba. Here we can also see high Sabi regions or high Z-score regions in the north, but also in the south. We were looking at the ones in the south because we quickly ruled the northern ones out as natural vegetation development. But in this area over here, we investigated a bit further because this was the first example where we could see human activity, which seems to be linked to the increase in vegetation development. So here, for example, you can see a lot of measures taken to reduce surface water runoff after rainfall. These horizontal structures over here. You can also see land enclosures filled with further horizontal structures. There's some cropland, some agriculture activity, but it's not the dominant landform. So we determined that this might be an interesting area to look at, because here we can clearly see that human activity has a positive influence on the vegetation development of the region. So that was one example where we think that's positive, that could be interesting to look into more detail. And to quickly show you the third one, it's called Biofadisi. Here as well, we can see that the area has a good development, vegetation in our time frame. And looking into this settlement, for example, here we can see a small settlement. We can see that there has been some agricultural activity, but switching on a newer image, we can see that there has been an intervention. So there is the creation of a new water basin. We can see that the settlement grew in size, and we can see that some agricultural area over here is not used any longer. So on the west side of the settlement, but we can see, looking at the overall region, that the creation of this water basin and the increased settlement activity had some positive effects on the vegetation after all. If you're wondering what this red circle here is, to construct this basin, it was necessary to get rid of some trees, which were around the old basin, and that's the red area here. So you can see that this Z-score method actually works. We can actually see changes in vegetation. I think that's always great to have this bit of peace of mind to see, oh, it's really working. Okay, great. Even though it's a negative change in this very small area, but that's understandable. And with that, I would hand it over again.
Thanks so much, Gunnar, Hodan, and Basma. So, this series is called Under the Hood. So we give you a behind the scenes look. So we know that some of it's a bit technical, and that's why maybe before going into the Q&A, I would want to ask Basma just to give us sort of, zoom out a little and give us sort of the bigger picture of what this is all about, what we're trying to do here, and so how we go about it. If you can hear me, Basma, I know you're having connection issues. Okay, you're back.
Yes, thanks, Andy, and thanks, Gunnar and Hodan, for the presentation. So what we're trying to do here is that we're trying to look into communities that were able to preserve and enhance their rangelands since the last drought in 2016 and 2017 by observing an enhancement in their biomass. And as Gunnar explained, and as Hodan also explains, is that surprisingly, the beginning of this project was actually totally different. So the beginning of the project is that we wanted to see communities or pastoral communities that are able to maintain their livestock. And there was this idea that we had that we wanted to enumerate livestock using remote sensing data. But after going through and validating the data, we found out that this is impossible. And we decided to look into another indicator, which was the biomass, in order to identify those positive deviant communities. Because if they are able to enhance and sustain their rangelands, accordingly, or consequently, they will be able to maintain their livestock. And by using this remote sensing data and using the administrative data, which is the land cover data, we were able to somehow identify areas where there could be, or there's a high likelihood to identify those local innovations, and also to identify those different factors that work together in order to enhance and sustain those rangelands. And by what or through the stages that Gunnar said, we were able to narrow down the search space, and we were able to further validate those potential positive deviants for the next stage, where we would go there and do a positive deviance inquiry and collect the thick data to identify those practices.
Thank you, Basma. And so if you want to ask a question, you can either raise your hand or put them in the chat. And while you're putting your questions here, I'll ask another question to all of you, Gunnar, Basma, and Hodan, which is just going back to the term positive deviant. Who or what would be a positive deviant in this context? How would you describe a positive deviant for this particular pilot?
So the positive
okay. What would you doing? Would they be doing differently or better than people around them or groups or communities around them?
So the positive deviants in the case of Somalia would be the communities that were able to use those water and soil conservation techniques that enhance their rangeland health. It could be also like policy factors, like land tenure policies that were applied or properly amplified within those communities that enable them to enhance their rangelands. It could be an idea of having those communal land or rotational grazing, or all those practices that are also could be attributed to better rangeland health. So eventually, positive deviance in this case will be the rangelands that were expected to be doing bad or expected to have been degraded in the past period, and they weren't like this. They did much better than what we expected.
Okay, thank you, Basma. There's a question by Ahmed, I think. Right? You want to speak up and ask your question?
Yes, thank you very much, Andreas. I would like to first start by thanking the presenters for this illuminating presentation. I just wanted to pose one or two questions and maybe one suggestion. I'm not sure there is a GIZ study on the economics of land degradation initiative. We had that study undertaken in Somaliland. So I'm not sure whether you have seen or incorporated or read through that document while doing this study. That's just one. And then the other point, there are a number of indigenous and exogenous variables that you need to consider when looking at the rangelands in Somaliland. Issues to do with charcoal production, issues to do the use of alternative cooking methods in the areas where you say, for example, there is a positive deviance. In the cities around there, what do they use? Do they use efficient stoves? Do they use traditionals? Do they use LPG? I think those are things that you need to consider in your study. And the other point I wanted to also highlight is, I haven't seen the Ministry of Environment and Rural Development in Somaliland among the the institutions consulted. That is the institution which does a lot of environmental conservation and trainings to communities in Somaliland. I think that you need to underline that. And then I have seen, for example, the Anlibah. We now, it's of course where you say it's a positive deviant, but did you consider that there was if I'm not sure but I have seen a proposal by Somaliland Development Fund to implement a rangeland rehabilitation project over there. I have seen that proposal. So did you consider that, whether if that project was implemented in that area, then how could we say that there is a positive deviance in that area if the other place did not receive? So I think the issue to do with the comparison, as I think one of the presenters said, we need to make sure that we are comparing apples to apples and not apples to oranges. I think that is, I just wanted those are the points I wanted to raise. And did you also consider on the offtake of livestock, how many animals were being sold out in those from those villages? I think those are things that we need to consider in our data. I think there was maybe some secondary data that we can find out. Over. Thank you very much.
Thank you so much for I think four really good points. I'm not sure about the first two. They're quite specific, so maybe Hodan can respond to them. But I think this third and the fourth are about homogeneous grouping and exception responders. I would assume maybe Basma or Gunnar might be able to respond to that.
Okay, so I'll just start with the point on charcoal production. We did actually take that into consideration. However, we do understand that there is some gaps with respect to the data sets on areas that have active charcoal production. We were using a map by FAO, if I'm correct. It was FAO, yes. So there are still some gaps, but during the stakeholder validation, we did ask a lot of our stakeholders, especially the Ministry of Agriculture, Ministry of Livestock and Fisheries, and the Ministry of Environment, the Department of Urban Development and Rangelands. And they also had like this, there were some areas that have well-known coal production areas, but I think we will definitely only know once we go into the field during the quantitative analysis part, the qualitative analysis part. Okay, and on the ministry, we actually did talk to the Ministry of Environment, the Department of Rural Development and Rangelands. I might have just skipped it while I was presenting. So.
Thank you, Hodan. Basma, Gunnar, do you want to respond to the other 2 points?
Maybe on a more general remark, what we did incorporate in our analysis is also driven by what data was available to us. So, for example, we would have loved to incorporate chocolate production, but all we found was a map depicting areas which were potentially interesting for chocolate production, not actually used for chocolate production. And that's a typical example of where we just had to go with the data, basically. And we tried to determine as many data sources as we possibly could. And I'm sure we missed some, because you always miss something. But in this case, we were really driven by what's available to us. And that's also why I highlighted the importance of the validation and also the stakeholder validations and the qualitative analysis on the ground, because that's where you get the insights, right? We are just pointing into the right direction, or we're trying to do so. Regarding Gaan Liba, which you mentioned, yes, we knew that there is a potential intervention, but I think having an intervention that works and that produces meaningful results, that's still a positive deviance to us, because if that's something that's scalable and that's reproducible, I still think that this is interesting. And I think in the validation, we also wanted to talk about how to treat this case later on. But yeah, that's obviously a good good remark from your side, and we will take that into consideration and possibly get back to you with some questions.
Thank you, Gunnar. And maybe Basma also on that idea of exception responders and the different ways you can actually use and apply positive deviance, which might go beyond what we're trying to discuss today, but just give us sort of a sneak into what our thinking is around that.
Okay, sure. So the idea of the exception responders is trying to see why does interventions in some areas work and why do they not work. And we're trying to see how the communities are engaging with those interventions. How are they able to maintain them and sustain them long after the intervention happens? And when it comes to Gaan Liba, in addition to what Gunnar said as well, is that we were aware that there is a government reserve in some area in this 5-kilometer buffer, but there was an area at the bottom of the Gaan Liba buffer, which doesn't seem to be included in the government reserve, but it looks like an agro-pastoral community within the 5-kilometer buffer. So this is why we thought that this also could be something interesting to investigate. And there was this idea that also was mentioned, which is trying to know how many animals were sold. We tried to enumerate the number of livestock. This was something that we attempted to do at the very beginning as a proxy of the number of livestock within communities. But the problem that this data was only found at a very aggregated level. So it wasn't at the level of communities or villages, which we are looking into, but it was at the level of region. And that's why it was hard to associate it to a community behavior. But maybe we could try to find this aggregated data, or if you know anyone who could provide this data, this would be very useful data.
Thank you, Basma. And I'll just keep asking questions if no one else wants to ask. I have a few more. So one is looking a bit beyond this current phase that we're working on, which is about quantitative data analysis, even going beyond the qualitative data analysis, but actually once we go to scaling and implementation of what we've learned. And Basma, you mentioned earlier 3 different factors, structural, transferable, and behavioral factors. Can you link that, that discussion to what we might be able to do with the insights and the findings we generate when it comes to scaling the positive deviance behavior, but also maybe thinking about ways of sort of policy interventions and ways of sort of transferring and scaling the sort of the good practices that were identified to other parts of the country.
I'm really sorry, Andy, but your question wasn't very clear to me. So
sorry,
can you please?
I know I'm trying to link the different sort of factors, the structural factors, the transferable factors, and the behavioral factors, and depending on which one contributes most to the positive deviant sort of innovation or practice, which of how would that help us to come up with interventions or solutions? Would it be scaling the behavior or thinking about ways you can actually have a policy intervention, programmatic intervention? So the whole discussion is sort of what will actually come after we understood what makes a positive deviant. Was that
okay?
Better?
Yeah. Yes. Thanks, then. So this is really very relevant to the case of Somaliland, because we realized that in the PD pilot that we're doing in Somalia, it's very hard to attribute the performance to individual pastoralists or agro-pastoralists, but actually the problem is much more complex than that, and we have to view it with a systemic lens. So we realized that when we go to those communities, we will have to look into the different proportions and the different mix of livelihoods within the community. So maybe there are more agro-pastoralists and less pastoralists, or there has been a move into an agro-pastoralism. This is one thing. It might be that there has been certain policies that were enforced there in a certain way, along with the idea of using prosopis for charcoal production. Like, understanding this mix of policies, livelihoods, individual practices and behaviors, and based on what we're going to identify, there would be two types of interventions. So the transferable individual kind of interventions will be more of community interventions targeted for the communities. And the more systemic structural factors that are leading to the positive deviance would be targeted for like stakeholder interventions. So based on what we're able to find there and the factors that we're going to find there, we're going to design different interventions for the different stakeholders. I hope this answered your question.
Yeah, thank you, Basma. We have only 2 minutes left, and I know Andreas wants to say a few words. So that last question, Ahmed Abdi, will take that with us, and we'll try to respond that. If you share your email address with me or someone, we'll get back to you. But we don't have the time for that now, because that's, I think, a more difficult question. Or maybe Hodan will be able to answer it in the chat as well. Okay, so I'm handing over to you, Andreas. So thanks again, Basma, Hodan, Gunnar, and over to you, Andreas, for wrapping it up.
Thank you so much. Thank you so much, Andreas. Thank you so much, Basma, Gunnar, and Hodan. I mean, I know the pilot quite well, but I think it's always exciting to hear about it again. Thank you so much to the audience for joining us to our first part of the Under the Hood series. Thank you so much for your really insightful reflections and questions and comments. This is the first of a larger series. The next presentation that we're going to have on this initiative will be on Wednesday, and this will be on our pilot in Ecuador, where we're looking at sustainable rangeland management. No, where we're looking at sustainable cattle raising in the Amazonian region in Ecuador. There are two information that I would like to share with you. The first one is the landing page, where you can find further information on the upcoming webinars. And the second one is on our blog post on Somalia, which we just posted last Friday. We would be really excited to get your feedback, to get your comments, your questions. If you found this really interesting, please share in your network. And we would be excited to see you again on Wednesday. Thank you.
Thank you, everyone. Bye.
Thank you, Khamis.
Thank you, everyone.
Thank you for joining.
Bye.